Okay, now we're going to talk about some of the types of function symmetry. So you've all been working with parabolas for a while. Well, the axis of symmetry, the line that divides the parabola in half, we're going to pretend that I drew a perfect parabola, which clearly I didn't, but at the vertex point, there's this invisible dashed line that divides the parabola in two symmetrical pieces. And that should make sense. If you've got an x squared, well, 0 squared is 0, 1 squared is 1, negative 1 squared is 1. Let me move that kind of. And you've got these symmetrical pieces on both sides. So that's symmetry about the vertex, right? So if that vertex right there is -3, 0, where x is equal to -3 is the axis of symmetry. All right. Now we're going to talk about even functions. And notice, like a parabola, where the axis of symmetry hits, there's that invisible dashed line, and you've got two symmetrical. These are called even functions. And it doesn't have to just be a parabola. X to an even exponent on some functions. Now you have to be careful when you've got x to the fourth minus 3x cubed plus 12x minus 5. This function may not be symmetrical about the y-axis. It'll be symmetrical about something, but it will not be symmetrical about the y-axis. But if you have y is equal to x squared, that would be symmetrical. If you have y is equal to x to the fourth, which is one that looks like this, that would be symmetrical about the y-axis. All right. So if it's x to the even and it's symmetrical about the y-axis, that's called an even function. So for odd functions, odd functions are symmetrical about the origin. So, this is probably a little bit confusing, but odd functions are going to be x to an odd exponent. But remember, if f of x is equal to x cubed, which looks about like this one, that's an odd function. But if it's x cubed plus 4x squared minus 15x minus 12, that may not be symmetrical about the origin. So that may not be an odd function. I didn't try it out, but I'm guessing that it's not an odd function since it's going to hit down here at -12. But if you're going to have an odd function, one thing to pay attention to is the highest degree exponent an odd number? Then there's a shot that you'll have an odd function. And then we have non-functions that have symmetry. So a circle has symmetry, right? If you put these vertical line or horizontal line through the center, you're going to have some symmetry within a circle. Or if you have a sideways spacing parabola, that would be an example of x is equal to y squared, you're going to have symmetry about the vertex. If it was just this equation, x is equal to y squared, then it would look something like this. Then the vertex just happens to be the x-axis, so there would be some symmetry there. All right, and then now we're going to talk, so that's symmetry, and now we're going to talk about transformations. So remember, and we've talked about this with parent graphs, if it's a vertical shift, vertical means up and down, notice there's either addition or subtraction being made on the outside of parentheses. So for an example, if this original function is x squared, this shifted function right here would be up here at 2. So vertical shifts, the number's on the outside of parentheses, and it's whatever the sign is in front of it, that's what you're going to do. Originally I had +2, so this would be going up 2. If that would have been subtract 2, we would have started down here and gone up. Horizontal shifts, meaning they move left to right, that is when you'll notice there's something inside the parentheses with the x, but you always do the opposite. So again, if this would have been x squared, it would look like this, but then with this shift right here, the opposite of -3 is +3. So let's see if I can get this moved okay. We're just going to move over to +3, and that would be that graph. So horizontal shifts, you'll be looking at the inside of parentheses numbers. You take the opposite number of the value inside the parentheses with the x. Stretches and compressions. So if the original function, I didn't draw that one very well, f of x is equal to x squared, an integer multiplying by the x squared function causes it to be more steep. And then a fraction multiplied by the function, because look at it, it's 1/3, right? It's 1/3 as tall at any given place as the normal function. This right here, at any given x value, it's going to be twice the slope versus 1/3 the slope. And then reflections. So remember, a reflection is something like this. If you've got a triangle and you want to reflect it over the x-axis, and it just looks like a mirror image, right? That's what a reflection is. All right, so I'm going to give examples of a reflection for the square root function. So the normal square root function looks like this, right? The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. That's the square root function. If you take the opposite of the square root function, a subtract sign on the outside, the graph is going to be reflected over the x-axis. If the negative sign is on the inside with the x, it's going to be reflected, the graph is going to be reflected over the y-axis. And if you have both, it's going to be reflected over both. It possibly first reflects over the x-axis and then reflects over the y-axis. All right, that's it on symmetry and transformations.